The second part of question number 36 involves using the Newton quotient to find the derivative of tan x. So when we set up the Newton quotient, we end up with tan of x plus h minus tan x. So this is y1 minus y2 over h, which is the run. And we let the run go to 0. Now to apply this, we need to use an identity. So we're going to use this identity of tan of x plus h is equal to tan x plus tan h over 1 minus tan x tan h. Now, if you don't know this identity, we could either look it up, or alternatively, we could have used sine of x plus h over cosine of x plus h. Now, you get a slightly different looking identity when we do this. Okay, when we use the sum identity for sine and the sum identity for cosine, but it will be an equivalent expression, and we can just mess around with the algebra of this. This one here tends to be a little bit easier to use for this particular problem. So I'm going to apply the limit as h goes to 0. So I'm going to write in that identity. To do that, I want to put the 1 over h to the side here so that I can get it out of the way. And I'm going to replace the tan of x plus h with tan x plus tan h over 1 minus tan x tan h. And then minus tan x. Okay, so there's I've replaced my x plus h expression, so I've replaced that with this equivalent. And again, I don't really expect you to know this identity, but if you can look it up, or we can alternatively use this different identity, we can still do this problem. So let's do the algebra then. So limit as h goes to 0 of 1 over h. Now I'm going to get a common denominator here, so I can add these fractions. Tan x tan h, 1 minus tan x times tan h, minus, and this becomes tan x times my denominator, 1 minus tan x tan h over 1 minus tan x tan h. Okay, so I've now got a common denominator. When I multiply this out, I'm going to end up with some terms that cancel out. So this is the limit as h approaches 0. And I'm going to put this all over a common denominator. 1 minus tan x tan h. End up with tan x plus tan h minus tan x, so those tan x's are canceled out, minus, in fact I'm going to get rid of this bracket here and just make that a minus minus a plus, so this becomes plus tan squared x times tan h. Okay, so we can see that there's some terms that cancel out, so I'm going to get rid of some terms here. This tan x and this tan x cancel out, and I can see that if I group this with this, and this with that same divide by h, we actually have the identity that I established earlier. Tan h over h, the limit as h goes to 0 is equal to 1. So I want to regroup those. It also means that this 1 minus tan x tan h is kind of getting in the way of this. So I'm just going to put it off to the side. And if I take a closer look at it, this is going to be tan of 0, which is 0, times tan x, which is 0. So this is just going to reduce to 1 anyways. So I'm just going to put it off to the side. So limit as h goes to 0, 1 over 1 minus tan x tan h. And then I'm going to put in my tan h over h minus, is that right? Minus, this becomes tan squared x. Okay, just double checking my signs here. That should be plus. Sorry, that's going to be plus. Okay, so I'm going to end up with plus tan squared x. And then the tan h and h I'm going to group together as tan h over h. So at this point I can now apply my limit. This limit is equal to 1, this limit is equal to 1, this limit is equal to 0, which makes this all equal to 0. So I'm just going to start plugging in. I'm going to apply my limit. I'm going to plug in my 0, so 1 minus tan x times tan 0, which is 0. Tan h over h is 1, plus tan x squared, and tan h over h is 1. So what ends up happening then is I end up with, this is equal to 1 times 1 plus tan squared x. This is an identity. Tan squared x is really just equal to secant squared x using the Pythagorean identity. And now we've shown using the definition of the derivative or Newton quotient, we showed that algebraically we get the derivative is equal to secant squared x, which is what we established as a formula. So we would never really expect to do this on a test or anything like this. This is just an algebraic exercise, but we do end up with the same result that we did when we put it on our formula sheet.